Okay, we are starting Unit 4. I've given you the Unit 4 cover page. It lays out what we are covering for this unit. In the last unit, we did transformations, which was translations, reflections, or rotations, right?
Yeah.
I said there's a fourth transformation called dilations that we would not be doing until after spring break because dilations changes the size of the shape. And before spring break, I wanted everything to be the same shape, same size, right? Okay, so spring break's over. Welcome back. Hope y'all had a great week off. We are 35 days left in the school year.
Dang.
It's going to go back quick. There is a lot going on. 7 school weeks, no more 4-day weeks unless we have like some type of inclement weather, which at this point now would be floods or tornadoes. All right, so listen. Dilations. When you go to the eye doctor and you get your eyes dilated, the pupil gets really big so that the doctor can shine the light and look in the back of your retina, right?
Yeah.
When you walk outside, it's very uncomfortable. When you walk outside without sunglasses on a bright sunny day, the pupils do what? They dilate very, very, very small because your eyes are adjusting to allow a certain amount of light in so your brain can process what you're looking at, right?
Yeah.
Too much light, your eye adjusts to compensate for that. Not enough light, your eye adjusts to compensate. A lot of people think dilate means get big only, and it does not. Dilate means just changing in size in general, okay? So it could get big, it could get small. Before we actually do our dilations guided notes, I need to make sure that you remember how to plot points, which is why you have this nice little warm-up, which is a breath of fresh air, because you are just plotting points. It is page 59, and I do want to draw your attention to how to read this so you don't mess up. First of all, I would put a mark next to each point as you plot it so that you don't get lost with where you are. Remember, these are X, Y coordinates. X controls right or left. Y controls up or down. So the very first point is right 4, down 2. The next point is 0, -2, and you're going to connect it. Then the next point is -5, -5, and you're going to connect it. Now, you will notice when you get right here, 14, -1, then it says stop. That means you pick your pencil up, and you no longer connect anything. You start new right here. So this is a little series of connections. No, you are not connecting the last one to the first one. That is a big no-no, okay? You are not connecting the last to the first. So we're going to work on this for a few minutes, and we're going to see how well you do. It is an actual picture. It's actually pretty cool when it starts to come together. And then we will move on with today's lesson. All right, we're going to look at dilations. We're going to spend 2 days on dilations because there's a lot to talk about with it. And, of course, I want to make sure you know how to do it, how to dilate, because this will be on your quiz, which will be later this week, okay? So let's talk about when you're dilating. We already said that if you go to the eye doctor, your pupils get dilated to be larger. If you walk outside in the sun, your pupils dilate to be smaller. So math terms for that would be if it's a reduction or an enlargement, and those go hand in hand with what the type of dilation is, okay? If we're dilating something to be smaller, it's called a reduction. If we're dilating something to be larger, it's called an enlargement. When you are dilating, how do you determine which type of dilation it's going to be? It's all centered around what's called the scale factor. The scale factor, if you think of a Hot Wheels car, any Hot Wheels car is as best as they can the direct, like the exact copy of the life-size car, right?
1 to 24.
Right,
Pretty
and
much.
it's on a scale of, like you just said, 1 to 120. What is it? 1
It's
over
1 to 24. Is a Hot Wheel.
So anyways, they take the life-size car and they shrink it down to just a fraction of the size, and that's how they create the Hot Wheels car. And that's why it looks exactly like the life-size one, because it's a dilation, okay? If we were talking about the slope of a line, what lowercase alphabetical letter refers to the slope of a line?
M.
Thank you. M refers to the slope of a line. There is a lowercase alphabetical letter that refers to the scale factor of a dilation, and it's K. It's lowercase k. That stands for scale factor. So if on your sheet of notebook paper, maybe up above where you glued it down, since there seems to be a little bit of room, you may want to make a note that K equals scale factor. The scale factor is going to be a number. The number that the scale factor is dictates what type of dilation you have. If the number is smaller than 1, then clearly it's shrinking. It's a reduction. If the scale factor is bigger than 1, then it's getting bigger, right? So let's go with an easy example. If the scale factor was the number 2, that would mean that the pre-image is going to double in size, right? If the scale factor was 1/2, that would mean the pre-image is going to shrink by half the size. Does that make sense? Okay. You have an example of each on here. You have a little chart to fill in with your coordinate points. We need to fill in the actual pre-image points. Remember, the pre-image is the one you start with. So we have A, B, and C, and we need to write the coordinate points for A, B, and C. So what are the points for A?
-3, 3.
-3 and 3.
Yeah.
What about for B?
-3, -3.
And C?
3, -3.
Okay, we're going to dilate this. If you look right here, this is our example. We're going by a scale factor of 1/3. So that means that the shape is going to do what? It's going to shrink. It's going to shrink by 1/3 of the size. To dilate, I don't know if you want to write this at the bottom of your notes on the notebook paper or wherever you have room. To dilate a figure, multiply each coordinate point. And when I say that, I mean X and Y by K, and K is your what again?
Scale factor.
The scale factor. You're going to multiply X and Y by the scale factor, and that's how you dilate. Okay? Write that down. Okay, so we have the image, the pre-image, triangle ABC. We're going to dilate it to create A prime, B prime, C prime. This is where you get your calculator, and you're going to multiply the X and the Y's by 1/3. So the X and the Y's by 1/3. So look at A. We're going to do -3 times 1/3. You know how to type that in, by the way?
Yeah.
So you'll type -3 times 1/3 can be entered one of two ways. You can enter it as 1/3, or you can enter it as the little fraction shortcut. -3 times 1/3. You can do it that way. Or you can do -3 times and then do alpha y equals and do 1/3. Either way works. Alright, so the x coordinate for A prime is -1. What's the y coordinate? You get it the same way. You're going to take +3 and multiply by 1/3 and you get 1. Then you're going to repeat with B prime and C prime. And those are all just 3 or -3s, right?
Yeah.
So you should be able to fill this in without having to continue to use your calculator, right?
Yeah. You want to
So what's B prime?
-1.
And what's C prime?
1 -1.
And now we're going to graph it. And it helps to label it. So you can see how the triangle got smaller, and it's because the scale factor was 1/3. Notice though it's still the same shape, right? Notice it didn't pivot, it didn't like get up and slide away. It stays kind of within the same space, and that's because we're dilating around the origin, the center, 0, 0. Because we're dilating around the origin, we're allowed to just multiply the scale factor through the points. All right, let's do now an example where we're enlarging it. Let's find the pre-image coordinates. We got D, E, F. Then we're going to find D prime, E prime, F prime. What are the coordinates of D?
-1.
What are the coordinates of E?
-1.
Thank you. And now we're applying the scale factor of 3, which means it's tripling in size. It's just a matter of multiplying all of these numbers by 3. I love dilations for the simplicity of them. Just wanted that dramatic effect of, I'm going to leave it there. Look, I've got the thumbs up there.
Mine's charging.
Okay.
I don't know.
We're pretty good on not getting on our phones. Because my phone doesn't even work in here, so I've got no you know.
Yeah. Are you not promoting or anything about it?
Oh yeah, dude, Gracie.
Bro, said? You didn't state any of those.
All right. So what's D prime going to be? What's D prime going to be?
-3.
So D, let me remind you, D is -1, 1. we have a scale factor of 3. So that means we're going to multiply each of these by 3, which gives me d prime negative 3, 3. Right?
It's just multiplication.
It is. That's all it is multiplication.
That's what the brain did.
All right, and then you're going to graph it. You should notice that the two examples that are on the front of this flip book are the exact opposites of each other. They produce the same image, and that's because I wanted to show you the difference between if I was to give you this picture, just this picture, and I said to you, what occurred here, you would find the letters that don't have apostrophes to notice which one's the pre-image, and then you would say, oh, this was a shrink, this is a reduction, right? And if I give you this picture, you would find the letters with no apostrophes, and then notice that, oh, this is an enlargement. Do you see that? Also, if I was to say to you, instead of giving you the pictures, what if I just gave you this, and I said, what's the scale factor? Well, you would have to take note of what's happening first. You need to know what direction you're going. Because if you go one direction, it's multiplied by 3. If you go the other direction, it's multiplied by 1/3. So you would have to say, well, if I went from -3 to -1, it got smaller, so that means it's less than 1, and that would tell you that it's multiplying by 1/3. Go to the inside of your flip book. These are your 4 practice problems for tonight. You have until we dismiss. You should finish. But if not, then you also have flex tomorrow. And yes, I am checking to see who has all 4 of these filled in. You will be going about it the same way. Let me brace you right here. You see that it says the scale factor is 2.5.
Yeah.
So you might be thinking, how am I supposed to plot a half?
Whoa.
That
What?
just scared me.
What was
Between
that?
the sneeze and whatever was on the other side of this wall.
Somebody hitting it.
Hold on. So you might be wondering, how are you going to graph a half point right here? You just go halfway to the next line. So for instance, let's see, what is this, H-I-J? So H-I-J. So H is -1, -1. If I was to find H prime, I would multiply by 2.5. So it'd be -2.5, -2.5, right? So when I go to graph that, that just means you're going to go halfway to -3. So I'll go left 2, then halfway, down 2, then halfway. So it's kind of hovering, which is uncomfortable. I get it. But these numbers over here should be accurate, even if you accidentally graphed the half wrong. Okay? Sometimes the scale factor might be an ugly fraction that is actually a really pretty decimal. So for instance, 1/2. What is that as a decimal, y'all? 0.5. So you could multiply by 0.5 if you didn't want to multiply by 1/2. Now, what I'm about to say, I'm going to say with like a small disclaimer. If you're just kind of easing into this, then I need you to tune me out. But if you already get this and you're kind of already bored with it, or you already see the connection, remember when you're doing scale factor, although you are multiplying by the scale factor, if the scale factor is a fraction and the numerator is a 1 in the fraction, what is the same thing as times 1/2? Yes, but in division, what's the same thing as multiplying by 1/2? Division would be just divided by 2, right? Okay, so nobody answered me on that, so then just disregard. I was just going to point that out because sometimes people say, well, aren't you just dividing by 2? Well, yeah, if the scale factor is 1/2, you are. But if the scale factor was, say, 3/2, you're not there. So just multiply, okay? Multiply with the scale factor, all of the points. Knock these 4